This video is about exponential functions. So we want to know what those look like and how do we work with those functions. So our first example that we're going to look at, so these help you with the lesson that follows, is we have an exponential function. And our exponential function is f of x equals 8 to the x plus 1. And then we have a table of values that they have given us. And so let me fill those out real quick. Zero and 2, 1/3, and 3 and 5/3. Okay, so they've given us a table of values, which means that the x value that's given is plugged into the function itself, and we're given the value of y, or f of x, in return. And so in this case, they left one out and want us to find that missing piece. What is this one? So how do we find that? Well, we're given the x value, so we want to plug it into our function and figure out what that is. So we have 8 to the 1/3 power plus 1. That seems a little strange, but we also remember that we can rewrite these exponents as roots, radicals. So that can be written as the cube root of 8 and then plus 1. Well, cube root of 8, that means we're looking for a number times itself 3 times that gives us 8. So what number times itself 3 times gives us 8? And the answer is 2. And then 2 plus 1 is 3. So what is the answer that goes there? The answer is 3. Let's look at another example. They give us a function, f of x equals 4 to the 2x minus 100. They tell us that the domain of this function is all real numbers. And they want us to find the range. So we have to remind ourselves, what does that mean? So the domain means that it's all the x values. So any x values that I can plug in there. And when it says all real numbers, that means I can plug pretty much anything into that function and not have any issues. So we need to find out what the range is. So the range on this one is all the y values. So what are those y values going to be? So, how do I find that out? Well, I can do a couple of things. I could potentially graph this and figure out what that is. Or if I know, in essence, what these functions kind of look like, then I might be able to get an idea of what they are. So, couple things. These functions tend to look very interesting. They'll kind of either go like this and they dart up. That's why it says something's growing exponentially. It's because it goes up pretty quick. Or they might go up this way pretty quick. Either direction. That's what these look like. So, now that we know that, what could it possibly be? Well, if we also use our information that we know about transformations in graphs, we know that having a number added or subtracted here moves the function along the y-axis either up or down. So if I know that an exponential function tends to go like this along an axis, whatever it may be, then I know that the bottom of that is moving down so many spaces. So with this in mind, that helps us determine our range. So it will go as low as -100 and then up from there. So with this being roughly -100 on our graph, our range means that that's the lowest it's going to go, -100, to all the way up, infinity. Yeah. So our range is going to be that y, or f of x, either way, f of x is going to be greater than -100. So several different ways to write the same answer. All right, last example. Okay, they give us a table again. So this time it says time, T, and temperature, Y, and give us some information with that. 0 to 100, 1, 150, 2, 112.5, and 3, 84.375. Okay, and they want us to find the equation. So based on this information, knowing that they plug in these values for the temperature or time and get the temperature, what is our equation? So they're assuming this is an exponential equation. Okay, so we know that anything to the 0 power is 1. So right here in this first column, that gives us a lot of information. Anything to the 0 power is 1. So we've got to remember exponential means that the exponent itself is the x. So anything to the 0 power is 1. So with that in mind, that means that they did anything to the 0 power is 1, but they got 200. So now we know that we have 200 times something to the x power is our equation. Now, anything to the first power is itself. This column right here. Anything to the first power is itself. So what times 200? So what we have to ask ourselves is what times 200 equals 150? Well, let's divide those. So 150 divided by 200, and that will give us our answer. So whether you use a calculator or not, we get 3/4 or 0.75. And so that's what's going to go in our parentheses that I created, 0.75. And then we can always test it with these other points. So if we plug in 2, if I take 0.75 to the second power and then multiply it by 200, do I get 112.5? And then I could test it here as well. But our equation then becomes 200 times 0.75 to the x power. That's it for this video. This is the time that you will give me a call and we will talk about this video and I will answer any questions that you have. You'll also use this information to help you on the lesson that follows. Have a great day.